Hello everybody, Don KK4QAM here. It's been a while since I posted a video. I thought I'd give you a little quick update. A while back I started a new project here for the Home QTH. It's an autonomous satellite tracker. It's an Arduino controlled satellite tracker with azimuth and elevation. It will also create its own web page so that you can connect to the web page, select your satellite, it will download the Kelperion data, and then you hit track. And it will engage the azimuth and elevation servos to have a continuous sweep on that satellite. I hope you enjoy it. Stick around.
Okay, let's try something different.
In this video, we'll be going over the parts used in the building of the autonomous satellite tracker. Stick around. First became interested in satellites. All I had for radio was the ever trusty Baofeng UV5R, and I did experiment with the tape measure Yagi antennas, and those are basically a version of a dual band satellite antenna that is made out of cut up tape measures and affixed to pieces of PVC pipe. I never had any very good luck with making contacts on those, although the reception of it worked extremely well. Later on, I did manage to find a good deal on an Arrow antenna, which is in the picture here now with me, as well as the UV5R, and I made several contacts with it over, I don't know, maybe a year or so, and then kind of lost interest to it. But recently I've been wanting to get back into satellite work, so I have wanted to experiment with a home control station. With that comes the need for new antennas, because I want to be inside my shack with a computer software running the Doppler shift for the radio, as well as tracking satellites. So here we go. Or as I should probably say, I did experiment with making some egg beater style antennas, and here is one that I made, just roughly pieced together with the matching sections that would be here under the tape. This is a 70 centimeter version. Here is a big ugly 2-meter version of it, and as you can see, without a large piece of wire it will not hold the shape very well. So after these failed, I decided to try and hunt down some parts to make a autonomous satellite tracker, or something at least automated. So I was looking at YouTube one day and I seen a video posted by Ham Radio Concepts that said something about an autonomous satellite tracker. So I went through the video and I followed his directions, and I looked and priced. This is what originally came in. Here is the Arduino Mega. Here is a Ethernet shield for this Arduino Mega that runs in these pin headers here. It's piggybacked off of it. Here's a TP-Link Wi-Fi nano router. You could use it as a hotspot, access point, what have you. This board here is the BNO055 9 degrees of freedom 9DOF, or the spatial sensor as it's referred to sometimes. This board here is your servo control board, or your PWM board. Here is your GPS board. This, I went ahead and ordered the ESP8266 breakout board from Adafruit, which is the Huzzah, I think that's the correct pronunciation, as well as I had some buck converters here already, so those will be thrown into the kit as well. This board here, the ESP8266, is an Arduino controller, and it will essentially take the place of this Ethernet shield as well as this Arduino Mega. The original design was built on an Arduino Mega and the Ethernet shield and this Wi-Fi router here. Here I was trying to get an idea of sizing for layout and whatnot with the Mega, which is shown here on the bottom, and the Ethernet shield piggybacked on it. 2 buck converters, the Wi-Fi router, the PWM servo controller. Here's the 9 degrees of freedom, the spatial sensor, as well as the GPS board. This, however, is not the way that I went. Here you can see that I have attached the header pins to the pulse width modulation, and these 2 screws on this terminal strip is where the 6-volt power comes in, and you have actually 16 outputs for servo controls. Communications on the left and the right with your 3.3 volts coming in. That's basically a pass-through header. Bring it in on one side and you can take it out to another board or device on the other end. Here is the bottom side of the servo controller, and you can see it's a 16-channel 12-bit PWM driver. It's a PCA9685, I believe is the number for it. Here is the GPS board. Connections here on the headers, your voltage, ground, RX, TX, and so forth. And here is the little snap fit connector for the external antenna. Bottom side of the GPS board with a coin battery slot in here to maintain something similar to a real-time clock. This is your 9DOF or spatial sensor. It's actually the BNO055 board. Header pins on both sides for communications and power. The underside of it, information as well as the model number. Here I was initially trying to start getting everything laid out and loaded and working, basically just seeing what kind of space I would need in the control box. I actually have the Arduino Mega and the Ethernet shield powered up here at this particular point, but the issues that I found ran through this connection right here for the communications and control of the Ethernet shield from the Arduino Mega. This is called the MISO port, M-I-S-O, and after Googling this, there's a lot of problems with that, as well as other issues, but the ones that I narrowed mine down to were dealing with this port here. Now you see you can put a micro SD card in here for data logging. So I decided once the Arduino Mega would not work, I would switch over to the ESP8266. And like I said before, the one that I have is called the breakout board, which is right here. And as you can see, there is no USB connection to program this with. So you have to use a USB to TTL converter, such as what I have here, and I already had this one. So, you know, it just worked out. You have your TX, RX, 5 volts, and ground connections that come across. When you start loading your code, you will have to hit a sequence of these buttons, the ground and the reset and the flash button. That's what they are, and in order to get it to load. In hindsight, there is an ESP8266, I think it's a Featherboard or Featherlight, that does have a micro USB plug on the board. It's my advice that if you go this route, that one would be the one that you should need, because it's a lot easier to program. Here we have everything up and connected and running. The USB to TTL converter here coming off the computer. The ESP8266 here with, I believe these are, yes, communications coming through to the servo board, as well as leaving the servo board to the spatial sensor. Communications, I may not have them hooked up here yet, also come over here to the GPS board. I have 5 volts here powering the GPS and the servo board, which also transfers over to the spatial sensor. Thanks for watching. I hope you enjoyed it. Look for more videos as they come out in the series of the build of the autonomous satellite tracker 7.3.